Okay, here's some more tree diagrams. So when you make a tree diagrams, a school sells baseball caps in 2 colors. Every time there's an event, you're going to list off a column. So colors, sizes, and fabrics. So the colors I'm going to list off are blue and white, and I want to leave more space for that. So off of the color, you should write the 2 sizes, adult and child. So adult, child, adult, child. Then off of each of these branches, you write your fabrics, cotton and polyester. So cotton, polyester, cotton, polyester, cotton, polyester, cotton, polyester. So the total is 1, 2, 3, 4, 5, 6, 7, 8. It's my tree diagram. Next example, suppose you go to a sandwich shop and they have 2 choices of bread, white and wheat. So I'm going to make 1 choice white, and I'm going to leave some space, 1 choice wheat, and 3 choices for meat, turkey, ham, and vegetarian. So from each white, you're going to do turkey, ham, veggie, turkey, ham, veggie, and 2 choices for mayonnaise and mustard for the toppings. So mayo, mustard, mayo, mustard, mayo, mustard, mayo, mustard, mayo, mustard. So to count the total, remember, you count the ends. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different options. So if you notice on this example, to figure out the total options, you can take 2 choices for bread, 2, 3 choices for meat, 3, and 2 choices for toppings, 2, and multiply 2 times 3 times 2 and get the total. That's a shortcut. Same thing with this one right here. You had 2 choices of colors. You had 2 sizes. And you had 2 fabrics. So you can multiply 2 times 2 times 2 and get 8. This is called the counting principle. If there are X ways, so if there are 5 ways, 10 ways of making choice, and Y ways of making a second choice, then there are X times Y. It's not writing very well. There are X times Y ways of making the first choice, followed by the second choice. So if you count the choices at each event, then multiply them, that's how you can get the total answer. So we'll use this. How many ways are there to monogram? So monogram means to put, kind of like embroider or sew letters on something. So if you have a shirt and you want to monogram the word math, how many ways are there to monograph something with 2 initials? This 2 tells us the number of underlines we should do. So an initial is a letter. So how many letters are there for choices for the first letter? There's 26 different letters. And for the letters for the second letter, there's 26 letters. So you're going to multiply 26 times 26 and get the answer. how many different ways are there to monogram something with 3 initials? So this 3 means I need to make 3 underlines. And so there's 26 choices, 26 choices, 26 choices, and you multiply them. How many 5-letter license plates? So we make 5 choices. If the letters O and I cannot be used. So if you can't use O and I, it means there's only 24 letters left. So you do 24 times 24 times 24 times 24 times 24. Okay, theoretical probability of an event. So remember, this P of an event means favorable outcomes divided by total. So we're going to draw a tree diagram to represent tossing 2 coins. So however many events you have is the number of columns that you're going to have for your tree diagram. So for tossing 2 coins, we're going to have coin 1 and coin 2. So if you toss coin 1, you can either have heads or tails. So coming off of coin 2, you could either have heads or tails, or heads or tails. So every time, so from this event, you have to branch off of the original one. So the total is going to be 4 because 1, 2, 3, 4. So tossing 2 tails means which of these gives me 2 tails. So this is heads, 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 tails, tails, heads, tails, tails. So this one right here is tails, tails. So that's 1 out of 4. What's the probability of getting 1 head and 1 tail? So this is 1 head and 1 tail, and this is 1 head and 1 tail. So this is going to be 2 out of 4, which we know is 1/2. So I'm going to draw another tree diagram. A store is selling iPods. They come in 2 models. So we're going to have a column for our models and a column for our colors. So our models are mini and regular. And our colors are, so from this mini, you need to make the spokes white, silver, black, gray. White, silver, black, and gray. So the total amount is going to be 1, 2, 3, 4, 5, 6, 7, 8. The total, you count the end. So it's 8. So what is the probability you get mini and black? So we're going to count up all of the ones that are mini and black. So this one's mini and white, mini and silver, mini and black. So this right here is mini and black. It's the only one, so it's 1 out of 8. What's the probability of getting a white? So this one, I'll change the color. This one is mini and white, so I'll highlight that one. This one's mini and silver, this one's mini and black, this one's mini and gray. Nope. This one's regular and white, so these 2 are white. So it's 2 out of 8, which is 1/4. And then what's the probability of it being regular? So how many are regular? So the ones that are regular are 1, 2, 3, 4. So it's 4 out of 8, which is 1/2. Those are regular.